Hi and welcome back to another LeetCode video. We're dealing with the problem of the day, which is container with most water. I already know how to solve this problem, so I thought today I would do something slightly different. Normally I post my attempts of solving LeetCode problems instead of showing you a problem solution. So since I already know how to solve this one, I thought I'd just make a recording that shows you how to solve it. And without further ado, let's just jump into it. So the premise is that we are giving an array of numbers that represent heights, and each height represents the height of a line or a bar. And our task is to calculate how much water can we trap at most between any pair of bars in this scenario. Now, the first attempt that you might think of is the brute force one, where we just try out all the different combinations of lines, essentially, of bars, and compute how much water is between them, and just remember, well, what the maximum was. So let's just implement this brute force approach. I think it's a good exercise. In an interview, you probably want to just name that and not implement it in space. And since we are going to deal with two loops, we already know it's going to be quadratic time for I in range length. Well, actually, for left in range length of height. And so this is going to be the left line that we pick, or the left bar. And then we iterate over all of the remaining lines, which then will be the right side of the area or in which we want to trap water. Now, how do we compute how much water is trapped in that area? Well, it's simple, right? We just pick out the height between left, and we have to pick the minimum of them, the left height and the right height, because as shown here, if the left is larger or the right would be larger, the other one isn't, we cannot trap water, it would just overflow. And then we multiply that by the distance between those two lines. That gives us the width times height. I have the wrong keyboard layout, which doesn't match up with my characters printed on the keyboard. So we have right minus left. So if they're 1 unit apart, this would be 1, and this would then be the area that we can trap between them. Now, we have to remember, of course, what the maximum is. In the beginning, our result is going to be 0. And then we're just going to update our result each time we compute an area. And it's max result, like so. I'll actually like it this way around. Cool. Yes. So let's run this just to make sure that it passes, that we have no errors. Actually, we do have an error here. Let me see. Height left, height right, that's correct. The minimum, the maximum of that, length of height. Left plus 1. Let me see. Right minus left is also correct. So we output 3. Oh, we're outputting area, not result. My bad. We run this again. That should work. Nice. So yes. And we can submit it. It takes some time because it's not the optimal algorithm. And time limit exceeded. So LeetCode doesn't even want to accept this solution. It's probably a correct one. It didn't find any errors, but it ran out of time because it's too slow. So there is a faster algorithm for this that allows us to actually do this in linear time and still constant space. And I'm going to show you that one next. If you think about it, and this is kind of the trick to this problem, which I guess is why they rated it medium in the beginning. If you pick, well, if you start with the left and the right, you compute the area between the left line and the right line, right? Well, why would you want to do this? Well, first of all, to maximize an area, you might want to try to maximize one of the sides of that area first. So If we start with the left and the right lines, we would be maximizing the width, so the second part of this multiplication. And now if we update these pointers by advancing the left and the right towards each other, we can try to find the maximum area, and we actually guarantee to find it that way. The only question is, how do we decide to move those pointers forward? Because clearly there's going to be a combination of these two pointers left and right that point to the exact correct two lines that create the maximum area. Well, and the trick is, let me just write this real quick. So we'll have a left pointer, and then I'll explain you the trick. The left starts at 0, and the right starts at the length of height. So our height array minus 1, since in Python arrays are 0. Well, the first index is at 0, so that's why we have to do the minus 1. And now we have a little while loop. While left is smaller than right, well, now we can still do the same calculation. We could still do exactly this. So we calculate the error between the two. But now, how do we advance the pointers? Well, if you have two lines and one line is larger than the other, which one are you going to advance? The larger one to run into a potentially smaller line, or the smaller line to run into a potentially larger line? Those are essentially the choices, right? We know that if we advance the line that is higher than the one that is smaller, we're definitely going to be reducing the area. Not only are we reducing the width, the distance between them, so the width in our area, but we're also reducing the height. So that doesn't seem to make sense. So what we want to try is we want to always move this side forward that is currently the smaller one of the two. So that's going to be, that is basically the trick or the way to approach this problem. So if height at position left is smaller than height at position right, well, in that case, we're going to say left gets incremented. Otherwise, we're going to advance right, and right, of course, needs to be decremented to move towards the left pointer. And then in the end, we just return the result. And that is everything you need. And I really like this problem because it's so simple. It's also result. Oh, I don't have result defined up here. And it's very easy to understand both visually and from the code, I think. So if we submit this, that should now work. There you go. And we've completed the daily LeetCode problem. So yeah, I highly recommend trying both approaches. And if you want to use this problem to practice for interviews, you should go through the usual, where you read out the description loud, ask clarifying questions, what are the constraints, then you come up with some ideas, explain them, do the runtime analysis before you write any code. Bonus points if you can already give two approaches that you could try, the brute force one, or maybe an optimized one, and then implement the code. Try to do it completely error-free. That also always gives a good impression. And yeah, that's pretty much it. Thanks for watching.